All right, area of rectangles and squares. All right, so the area of something is like, say you're going to put carpet in a room. You want to know how much carpet that you need to buy. So the area covers the floor of that room, the whole floor of it. Or how much grass you might need to plant for a field. You need to know the area of that field, and then you know like how many seeds or how much seeds or whatever to buy for that, how much that area will cover. And so that's what we're talking about when we talk about area. Also, like painting a wall, you need to know like how many square feet that wall is so that you know how much paint to buy. So it's very applicable to know how to calculate area. So there's a formula for area, especially area of rectangles and squares, and that is and it's sort of the same. We're going to say area is equal to length times the width. Now some people might say base times the height, and that's the same thing as length times width. Okay, so let's just look at a few here. If we've got we're going to do some rectangles first. So let's draw a rectangle. And if we just remember the properties of those rectangles, it just means that, both of those sides are always the same length. The length is the same on both. The width is the same on both. So if we're going to calculate one, let's just say this length is 27 and the width here is 6. Well, remember, area is just the length times the width. So the area of this, the length is 27 times the width, which is 6. Now remember, whenever those letters are standing next to each other, that always means to multiply. So the area of that rectangle is 162 square, and let's say this is centimeters. So it's always square, whatever your unit is. Okay, so let's just try another one. We'll do a couple of examples of the rectangles, then we'll go to a couple of examples of the squares. Let's say this is 18 feet, and this is 7 feet. So we have, again, area is length times width. Our length is 7 and our width is 18. So if we multiply those together, 7 times 18 is 126 square feet. And you can either write it how I did here and actually put square centimeters, or you can put feet squared. So either one of those works. Okay, let's just do a couple of squares also. So remember, when we're talking about squares, that means automatically if they tell you it's a square, then all 4 sides have the same length. And that's just a property of a square. So you might see that formula would be area is the side squared, because it would be side times side, which is side squared. So because all the sides are the same. So if we have a square, those are the ones that you just have to sort of watch out for. What if they just say that this is 6 meters? Well, if they tell you it's a square, then you can automatically assume, you can know that this is also 6. Every side is also 6, okay? So they don't always have to tell you that those are both the same. You just know that if they tell you that it's a square. But I also, you can also use the above formula, area is length times width. So the area of this side of this square would be 6 times 6, which is 36 then square meters. And we can do, that's pretty easy, but we can do another example for you. So let's see, what if we have one that says 5.4 meters, 5.4 meters? Well, area is the length, or one side, times the other side, or that side squared. So just know that's the same thing as this. 5.4 times 5.4. Squared means that. So sometimes it's easier to just know length times width. It always works. It's always the same. And that is 29 1600 square meters. Remember, I told you could either write it as square meters or meters squared. Either one of those is fine. Okay, so let's look at what if we have a, if you're told to find the area of some strange figure that's not a rectangle or a square. Let's see, what if we have something that might look like this? And let's go ahead and label. This is 3, that's 8, this is 4, this is 5, and this whole thing here is 12. Well, what can we do here? How are we going to find the area of this? Well, a lot of times it's easy to just go ahead and think, well, I've got some of this information. What if I cut this into two shapes and I find the area of, let's say, this part? Well, that area, and make sure you've got these right, the area of the purple part is going to be 4 times 5 because we're using this length, this width, 4 times 5. So the area of that is 20. Okay, then we might want to go and say, okay, now I can go find the area of this portion of that. And notice the 12 covers this whole side there. And so that's not one that we would need for that because we've already used part of it. So this would just be the 3 times the 8 because we're using this and this section. Remember, we cut this off right there. So the area of that would be 24. So the area of the whole shape would be the 20 plus the 24. So that area of the entire figure would be 44. And whatever units it is, whatever we would say, meters squared or something like that. So, okay, so that is how you would find the area of we call those composite type figures, where you can break them down and come in and find something else. We can do one more of those real quick. This is a popular one that sometimes is used. 0.8, let's say this side is 1.7, this is 1.8, 2.5, 3.4, okay, so you may have to say, well, how can I break this up so that we can come up with some of these? Well, I may have to say, let me break this off like that. This would be the 0.8 times the 1.7. So the area of this section times 1.7. That would give us 1.088 for that section. And honestly, even though it doesn't look like it, this section should be the same. We can try that. Let's see, that would be the 3.4 minus the 1.8 minus the 0.8. So that's also 0.8. Okay, so then we can say this should also be 1.7 here times the 0.8. So the area of that section is the same. 0.8, 8/10 I should say. And so that's also 1.088. And then we have the last section up here is, let's make it green. So what's the length of that? All right, well we know that the whole side here is 3.4, but we need to know what's this little section. Well, if we know this whole thing here is 2.5, and then we're told here that that is that 1.7, so, well, this part is from 1.7. Let's say that. So then we're trying to figure out what's the rest of that. If that whole thing is 2.5, subtract out that 1.7. So what's left up here is 0.8. So then for that green section up there, we've got 3.4 times the 0.8. So a lot of times you have to sort of use a little manipulation, try to figure out some of those. And I got 2 72/100ths. So now we need to add all of these up to get the total area of the shape. So that, let's go back to our blue. Total area of the figure then plus 2.72. So 4.896 is the total area. Okay, so just divide up those shapes into those rectangles, some squares, and you're able to find the area of those composite figures.